Good morning, it is Matt Rogers, and thank you for joining this channel. This is a promising time, and the signs that there is continuous to be a new and exciting adventure to explore tidal disruption events and use them as probes of supermassive black holes. Astronomers have watched as a supermassive black hole enjoying a stellar meal flash twice in a rare and powerful event. This double flash tidal disruption event could result from a black hole catching binary stars, allowing one to escape, then devouring the other. If so, further observations of this event, designated, could solve the mystery of repeating tidal disruption events. Folks, these tidal destruction events are so powerful that they make and can be seen from billions of light years away. What isn't common, however, is to see a tidal destruction event explode twice or more times, making this observation as a result of feeding supermassive black holes located relatively close to the Earth at around 408 million light years away in the heart of the galaxy. Only a handful of tidal destruction events have shown multiple flares to date. Recent estimates suggest at a rate of these events may be around 15 to 20 times less common than typical tidal destruction events. While these events may be rare, they have the potential to make an outsized impact in our understanding of the tidal destruction event physics by allowing us to study the earliest phases of tidal destruction events, indeed are unpredictable in detail. The first flash was detected in February 2022. At first it appeared as an average run-of-the-mill tidal destruction event. If a black hole snack on a star could be described as a run-of-the-mill. These events are very special because the light curve of the spectra are most normal of the small group of tidal destruction events to have shown multiple flares. Additionally, both of its flares were well studied in ultraviolet and X-ray light measurements and spectro, allowing us to compare the properties between the two flares robustly. This information gathered included the mass of the supermassive black hole responsible, as the team has estimated the central massive black holes of a mass about 3 million solar masses. This makes it slightly less massive than the Milky Way's supermassive black hole. Prior investigations of this event have suggested that the star involved in these flares likely has a massive similar of that of the Sun. What is unclear, though, is whether the star had a binary partner that escaped such a grisly fate. When misfortunate stars wander so close to the supermassive black hole, the immense gravity generated by the black hole masses, which can be millions of billions of times that of the Sun, generates immense tidal forces within the stars. These forces squeeze a star horizontally while stretching it vertically. As a result, the star is reduced to the massive stream of a stellar pasta. In the process, fittingly called the plasma, the spaghetti warps around the supermassive black hole in a flattened cloud called a corona. From there, some of the matter is gradually fed to the black hole. While scientists aren't currently sure what causes the flare of tidal destruction events, they theorize that the cause could be a supermassive black hole that has grabbed a binary system of two stars in the process called the Hill's capture. So-called Hill's capture occurs when a tightly bound binary star system passes close to a supermassive black hole and gets partially disrupted. After this encounter, folks, one of the stars is flung out at a high velocity. The star remains inbound to the black hole on an orbit that resembles a flattened circle. This highly elliptical orbit takes the star further away from the black hole than the swing straight back and becomes closer. In this situation, the remaining star is more likely to experience repeated partial tidal destruction events, meaning it is not completely destroyed at once and can be and also return to the further disruption. These bunch of astronomers at the University of Hawaii astronomer explains that this happens if the closest approach of the remaining star is within the tidal radius of the supermassive black hole. The further disruption powers another flare each time the star passes by the black hole. Eventually the star will completely disrupt and no further flares will occur. Adding that, the two flares appears to indicate as a result from a black hole repeatedly disrupting the same star. Although these astronomers are not sure yet of the two flares of the short separation of the flares in time relative of the typical tidal disruption event, this suggests of the rates of a single star disrupted two times. The observed separation between the two peaks, brightness of the two flares, is 720 days, assuming that this is a repeating tidal destruction event resulting from Hill's capture, like this, of the orbital period of the surviving star. Of course, folks, when you think of this in astronomical terms, the researchers are eager to confirm this theory. Fortunately, they don't just know where to look, they also know when to look. Folks, think about it. Third time is a charm. If the proposed scenario of a single star getting repeatedly disrupted is a correct one, then the team expects a third flare. The prediction of when the third flare shows and occurs based on the observation separation of the two flares. It is said, if the separation of the orbital period of the star, they would expect to see another flare occur when the star next passes close to the supermassive black hole in the early 2026. It goes on to say if the team fails to see another flare from the tidal destruction event at around February the 4th of 2026, then this won't prove the capture wasn't responsible for the double flaring. It is possible that the star was fully disrupted in the second flare and will not produce a third flare. There is also a slight possibility that this of two flares are independent of the tidal destruction event, and if so, we would not see the third tidal destruction event. The predictability of the potential third flare. It is also a boon for studying for these powerful disruption events as a whole. That's because it gives astronomers a tip of being advanced of observations rather than to wait for the tidal destruction events by chance. It also goes on to say that we can begin observing much earlier as an attempt to observe the earliest phases of the tidal destruction events as the debris stream settles into the acceleration flow. This is something that is essentially impossible to do for a typical tidal destruction events, since you know when they will indeed occur. Should the team detect another unusual flare, the scientists will follow up programs obtaining the data during this third flare to compare it to the first two flares. This could reveal if this tidal destruction event has more surprises in store. This information, surprise of the fact that such seemingly garden variety of tidal destruction events could exhibit this type of behavior. This is a promising sign that there continues to be new exciting avenues to explore tidal disruption events and use them as probes of supermassive black holes. Mars is bigger and brighter this weekend than it will be all year, and here's how to see it. Mars will make its closest approach to Earth this weekend, while rising to its highest point in the night sky. Okay folks, on Sunday, January the 12th of 2025, the red planet will make its close approach to the Earth at around 8:32 AM. This event causes Mars to appear bigger, brighter in the sky than usual, offering skywatchers an excellent viewing opportunity. Mars will be visible from New York City beginning around 5:43 PM. When it reaches the altitude of around 7 degrees above the horizon to the northeast, will reach its highest point 74 degrees above the southern horizon at around 12:29 AM. Folks, again 13th of January of this month, and remain visible for most of the night before disappearing in the light of dawn at around 6:58 AM as it moves to 14 degrees above the northwest horizon. Now folks, we've had many people in our community explaining what type of telescope could we use to look towards the heavens for objects and formations. Indeed, for the sky events and different events, I recommend a Celestron StarSense Explorer DX 130AZ as a top pick for basic astrophotography and the best beginner's telescope guide. During this close approach, Mars will be within the 064 astronomical units of Earth, whilst in the constellation Cancer. 1 astronomical unit equals the average distance between Earth and the Sun, around 93 million miles, around 150 million kilometers. Mars orbits the Sun at an average distance of 1.5 astronomical units. Its farthest distance from the Earth reaches a distance of 2.6 astronomical units. Folks, this weekend it will bring Mars the closest it has ever been since Earth, very close in 2022 when it passes within 0.54 astronomical units of our planet. This event will be captured by millions across the world. Please look up to the heavens. You will see Mars shining ever so bright than it has ever before for a very long time. Very important capture of this heavenly body in our solar system. During this opposition of the Sun's full glare illuminates the planet's surface as seen from the Earth, making it easy to observe by both amateur astronomers using backyard telescopes and the professional astronomers using space-based telescopes. During the Mars event, Mars will have the maximum magnitude of 1.4 appearing bright in the sky. Lower and also negative numbers indicate brighter objects in the sky. Although Mars will appear bigger and brighter during its close approach, it will still only appear as a glowing red starlight. With the naked eye, a pair of binoculars or a telescope will be needed to reveal the details of the planet. So indeed folks, by zooming in closely you'll be able to pick up the clarity of the evidence of seeing the celestial object Mars. Thank you for watching this video. I'm going to come back to you very shortly with more photography of our solar system, because indeed Other known heavenly bodies, including Mother Earth, is also being affected by the cataclysms of Planet X, NIBIRU.